Methane's one of the fastest ways we can start to slow climate change. I'm the science leader of the New Zealand MethaneSat Science Program. It's basically the closest I could ever possibly get to my actual dream job, Chief Science Officer aboard the Starship Enterprise.
Ignition. Liftoff. Liftoff.
The object of the MethaneSat mission is to advance the science of detecting methane from space, in particular from oil and gas facilities, but in the New Zealand context we hope to apply the satellite to agricultural sources of methane.
At a global level, methane is rising faster than we can explain based on what we know from the ground up. And so we need measurements to be able to understand exactly where those methane emissions are coming from and what's causing them, and then that tells us how we can solve that problem. Space-based observations can give us a spatial coverage you're never going to get from measurements that you take on the ground. MethaneSat will look at 200 by 200 kilometer regions, and inside that region, we'll have a spatial resolution of around 1 kilometer. So imagine a picture, and each pixel in that picture is a 1 kilometer pixel. It's also going to have a precision of around 2 parts per billion. Now that number probably doesn't mean very much to you, but to me, that's the same precision as an instrument that I could put on the ground here in New Zealand. And that is an extraordinary thing to get from a space-based instrument. New Zealand has a really unusual greenhouse gas profile. For most developed nations, the biggest greenhouse gas is carbon dioxide. But for New Zealand, the biggest greenhouse gas actually is methane. About 85% of all of our methane emissions are just from agriculture, because we're a country that feeds a lot of the world. New Zealand's an almost perfect natural laboratory as a place to test the agricultural applications for MethaneSat, because we've got a nice clear signal that the satellite can see. The second reason is we have this tremendous history of extraordinary ground-based measurements that are used in all kinds of satellite validation. NIWA has a research site at Lauder. Although it's a tiny town, it's one of those places when you mention to atmospheric scientists around the world who are famous, their faces just light up.
We help out quite a lot, actually. Ground validation sites like ours check that the instrument is measuring the same as us. This is a Bruker IFS 125HR Fourier transform spectrometer. There are a number of ways that we can look at a spectra. The first way that most people are familiar with is you just put it through a prism and you get the cover of the Pink Floyd album. This is the most complicated way. The rainbow that we get with this, but it's a rainbow that contains 1 million different colors. And we can look at each of those individual colors and see how much of what we're expecting to see from the sun is missing. The problem with greenhouse gases is that they absorb infrared radiation. We measure how much it's been reduced, and that tells us the amount of greenhouse gas, carbon dioxide or methane.
Methane has a shorter lifetime than CO2. But in that short lifetime, it can do a heck of a lot of damage to the atmosphere. It can really warm the Earth. In that 10 to 20 years, 1 molecule of methane warms the Earth as much as 85 or 86 molecules of carbon dioxide. And so if you're thinking about how fast climate change is happening and how we can slow things down right now, methane's one of the fastest ways we can start to slow climate change.
So the satellite will really show us a snapshot about how methane is moving around the atmosphere and how much methane is being released from different regions. So it will basically provide these maps of methane hotspots in the atmosphere. We can identify where the methane emissions are coming from. It requires quite big computational resources. So luckily we have a really good supercomputer here that can help us with these challenges.
Ultimately, New Zealand's methane emissions are pretty well known from the ground up, but we'll be able to not only improve our understanding of New Zealand's methane emissions, but be able to shed light on methane emissions from agriculture for countries all over the world where very little data is available and the uncertainties are very high. These are regions where you'd just never be able to have the kind of on-the-ground effort that we have here in Aotearoa.
It's important that there's a global effort to solve climate challenges such as methane emissions, because the climate doesn't matter where the emissions come from. We all inhabit the same Earth, and the atmosphere and the impact of greenhouse gases affects us all. A mission like MethaneSat offers the opportunity to touch on expertise from lots of different parts of the world, and in particular a collaboration between the US-based Environmental Defence Fund and NIWA, Rocket Lab and the University of Auckland.
One of the dreams of this project is being able to see how much methane emissions drop as a result of interventions that we might do. It's an incredibly important thing to be able to offer people when you've asked them to make change, is to be able to say how well that change is working and to be able to provide them with that feedback. In the short term, in the next 20 years or so, methane emissions reductions are pretty much the strongest lever we have to rapidly slow climate change. But because of the long lifespan of carbon dioxide, there's no pathway to climate stabilization that doesn't involve reaching carbon zero. And definitely do not edit that out. To you.